Remotely piloted aircraft systems, RPAS or drones, are able to carry out a variety of missions in urban environments, including traffic monitoring, civil infrastructure inspection, and photography. However, drone pilots can face multiple command and control challenges during urban operations. Dense urban areas, where streets are flanked by high buildings on both sides, can create urban canyons. In this environment, signal propagation can be blocked or received through multiple paths by reflection, refraction, or scattering off building surfaces, which diminishes signal quality. Drones rely on Global Navigation Satellite System (GNSS) for navigation, and they need an unobstructed line of sight to the satellites. Buildings can reduce the quantity of satellites that are visible to the drone and impair the drone's flight control system. The drone command and control link can be affected by the same phenomena, which can lead to total loss of video feed and control of the drone, especially when the radio frequency RF line of sight between the remote controller and the drone is disrupted. When assessing if the RF line of sight is disrupted, it is essential to consider obstructions in the first Fresnel zone, an elliptical space surrounding the signal line of sight. Obstructions that exceed 40% of the Fresnel zone radius can substantially weaken the RF signal, and you may lose the communications link even if you see your drone. For reference, the Fresnel zone of a signal at a frequency of 2.4 GHz over 400 meters would have a radius of 2 meters at the center. Electromagnetic interference, EMI, can affect the drone's navigation system and command and control link. Both natural sources and artificial sources can cause EMI. In urban areas, common EMI sources are power lines, telecommunication towers, and high-voltage equipment like electrical substations. Drone pilots should keep a safe distance from EMI sources to avoid issues. The closer a drone is to the EMI source, the greater the interference will be. The antenna orientation between radio transceivers greatly affects the strength of the signal received. An antenna misalignment can greatly reduce the effective range of the command and control link. When using a commercial drone, the pilot should follow the manufacturer's antenna orientation guidelines provided in the user manual. When using a custom drone, the pilot should be aware of the type of antennas used and adjust the antenna's orientation accordingly. Dipole antennas should be perpendicular to the drone, whereas patch antennas should point directly at the drone to maximize transmission range. To maximize the safety and operational success of drone operations in urban environments, the following recommendations should be followed. Keep a high number of visible satellites during flight by flying higher and far from buildings. Keep a direct RF line of sight with a clear Fresnel zone. Keep a safe distance from EMI sources. Ensure correct orientation of antennas. Expect an overall reduced command and control link range. For more information about drone safety, consult canada.ca/drone-safety.